Hello, 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 and welcome back to Shiksha Costa. Today we're going to learn how to find the interest rate and the term. Today we're learning how to calculate I, the interest rate per period, and the number of periods in a situation that involves compound interest. To start off, think about how long it would take for a $20,000 investment to grow to be worth at least double $40,000 if it grows by 9.4% per year and it compounds every month. This may be a little bit difficult for you to do at this point, so feel free to use graphing technology to find your answer. Pause the video here, pop open your favorite graphing technology, and see if you can find out how long that investment would take. Well, if we have a situation where we have an amount that is growing with compound interest, we know the formula to use is this one right here, where P represents the principal or the amount at the start, which in this case would be $20,000. The I and N represent the interest rate and the number of periods. So this is both per period. So if we want to look at a situation, over here where we're not really sure how many periods, but we know that this compounds every month, then we know that the frequency, or f, we use that variable f to describe it, is 12. Now, to find the interest rate for one period, we know that we won't get the whole 9.4% per year. We have to take that rate and divide it by the frequency to find, because this represents the amount for an entire year. We're trying to find out how much does it grow by what percentage each month. And we'd find out that, you know what, when I try to divide these, I actually don't get a very pretty number at all. So I'm just going to leave it as a fraction. To find out how many periods, well, we know that this compounds every month. So we'll have to take the term in or the number of months and multiply. Sorry, we'll have to take the number of years, the term in years, and multiply that by 12, and that would give me exactly how many months. So I'm going to express that just with 12t because I actually have no idea what is the number of years at all. That's one of the things that I'm actually going to find out. In fact, the question says, how long would it take? So clearly it's asking me for a length of time, which we're measuring in years. So going back to that formula here, I'm just going to plug in all the variables that I know. So the principal is 20,000. The interest rate is given here. The term, the number of periods is 12 times the term in years, but T is actually unknown. The other thing we do know, though, is that the amount is 40,000. Now, like I mentioned, at that point, it would be very difficult for you to isolate t because it's in the exponent. But one way that you can solve an exponential function is by graphing. And over here, notice I've graphed this exponential function. Instead of t, I've just used x. And I've drawn a horizontal line using the same graphic technology, y equals 40,000. And I just need to look over here and notice that, hey, over here, if I click right here, there's a point where these two intersect. And that looks like it's at 7.4. That's the value of x. And in this case, or t. And t was the term in years. So it looks like at about 7.40275 years, this investment will grow to be from 20,000 to 40,000. Of course, as long as it grows by 9.4% per year and it compounds monthly. And sometimes we'll find ourselves in a situation where we don't need to know just how long it'll take for an investment to grow, but we're on a fixed timeline. And in this case, Omid is in that situation. He wants to buy a new game console that's going to actually come out in 2 years. So he can't afford to wait longer than that. He only has $800 today, but his plan is he's going to invest it so that it'll grow and grow and grow. And after 2 years have passed, it compounds annually. It needs to get to a certain target. What is his target? The price of the game console. So he has to find out what is the rate of interest that he needs to get. If he thinks that the game console will be priced at $899.99, and there's also going to be a 13% tax. Pause the video here, see if you can figure out at least what is the price of that game console going to be. Well, hopefully you got something like what I'm going to get. I looked at the original price of the console. I said, okay, that's going to be about 900 bucks, and I know that it's going to be a little bit higher because I need to add a tax. Now, the total amount I have to pay is the base plus the tax. So how can I represent the tax in this? Well, this is in some ways 100% of the base cost. And the tax is an extra 13% on top of that. So in total, I've got to pay 113% of whatever this number, whatever 899.99 is right there. That's the base cost, whatever the base cost is. And so to do that, I take 113%, that's 1.13 as a decimal, of, so I multiply by 899.99, and that gives me my total, which I know that the amount that Omid needs in 2 years is $1,016.99. So he knows how much he has today. He knows how much he'll need in the future. This is the future value. And even though he only has $800 today, he has 2 years to wait. He has 2 years for his money to grow, but no more than that because he wants to get this thing pretty soon. Um, what kind of interest rate would he need? How do we calculate that? Pause the video here again and see if you can figure that out. Well, hopefully you saw that, this is a situation that involves a single investment. It's growing over time, it's growing over 2 years, and it's compounding every year annually. And that's the formula for a value that is growing with compound interest. Now, in this case, the future value that we need is 1,016.99. The present value that we have is 800. And the number of periods is two. There are 2 years because it compounds every year. How do we find out what is the interest rate for one period for 1 year? Well, in this case, if I gave you a value for I, the first thing you'd have to do, if we want to isolate I, if I gave you a value for I, the first thing you'd have to do is add one, and then take it to the power of two, and then multiply it by 800 if you were following the order of operations correctly. So I'm just going to write those down on the side here. So we add one, then we take our answer and we take it to the power of two, and then we take our answer from there and we multiply it by 800. And that should give us our final future amount of $1,016.99. Well, if we're trying to find out how to go backwards to isolate I, we have to undo these. We have to retrace our steps. So first, we will divide the side by 100, by 800, and that'll cancel out the multiplication of 800. And because we changed one side, we have to change the other side by in the same way. So when we divide these two, and notice when I tried, I got a really ugly decimal. So notice that I just left it as a fraction. Now I have to get rid of the power of 2. The opposite of a power of 2 is a square root. This is the opposite of squaring, is a square root. And so we can square root this side. That'll cancel out the square. And then just like over here, we have to do the same thing to the other side. Now I is still not yet isolated. We do have to get rid of this 1, and we can do that by doing the opposite of adding 1. We would subtract 1. That would cancel it out, and we subtract 1 on the other side. And when we finally evaluate this in our calculator, now it's a time that where it's like, okay, this is going to be this is going to be our interest rate for one period, which is 1 year. We get this decimal, which we can multiply by 100 to turn it into a percentage. And it looks like Omid's investment needs to grow at 12.749% approximately if he wants to reach this amount in exactly this time and he doesn't have any more money to spend. So it's up to him to find an investment product that can guarantee at least 12.7% per year. So in this lesson, we saw that, if we were trying to calculate the rate in terms for simple interest growth, it might be kind of simple, but because compound interest is exponential, it's a lot harder. In fact, these ideas are so difficult but so useful that mathematicians have created a special type of calculator just for them. It's called a TVM solver. And this TVM stands for time value of money. You can use this QR code to find a TVM solver that I use, or you could just Google this or look it up on any search engine to find your own. And when you do scan this, or if you want to check out the link, I'll throw it in the description as well. It'll give you something that looks kind of like this. This is what a TVM solver looks like. It's got all of these fields to input, and there's therefore lots of variables involved here. I'm going to input the following number. So for present value in the previous example, we saw that the present value, the amount that Omid had at the start, was $800. You don't need to worry about payments for now because Omid did not make any further contributions or payments into this situation, so we can leave that as 0. We know that in the future he needed $1,016.99. And we know that this took 2 periods where the periods compounded annually. The way to use the TVM solver once you have those filled out is to click on the button for the one unknown variable. And in this case, that was the annual percentage rate. So if I click on rate, it'll tell me that up 12.749, exactly how I calculated it. But notice how much easier it was to use a TVM solver instead of writing down the entire equation and isolating the variable. It's made even more of a benefit when you realize that, hey, what if it wasn't to the power of 2? How can I get rid of a bigger exponent than 2? Or what if the interest rate was not compounded annually? What if it was compounded weekly or daily? How would I find the annual interest rate from that? Notice how many more steps there are there, whereas a TVM solver can handily give you the final answer very, very quickly. So if we were in a situation where we were calculating the rate and the term for simple interest, an equation is really useful and very quick to actually isolate those. But if you're trying to do so for a situation that involves compound interest, it's much, much harder. For this formula, a TVM solver is a type of calculator that you can use to find those two values, the interest rate per period and the number of periods. You just input all of your values, but if you notice, you have to input the present value as a negative number. I'm not really sure why that is. The future value you input as a positive number, and then you to calculate either the number of periods or the interest rate per period, you have to enter the other one. Make sure that the payments are set to 0. We're going to learn a little bit more about payments in the future, but we are not making any contributions or withdrawals at the end of each period. To do so would be to create something called an annuity. And we're not going to worry about that for now. So just make sure that you've got 3 out of these 4 put in and that payments are set to 0. And then click on the other one that you did not have the value for. And the TVM solver will calculate and tell you exactly what that value is.
Let's take a look at one more example here. This is the same situation. Omid is trying to invest $800 today. He is trying to buy the console in 1 year. It's going to be priced at $899.99 plus 13% tax. But Omid can't find anywhere that will give him 27% interest. That's crazy high. So instead, he does manage to find somewhere that gives him 6% per year, and they even promise him that it won't compound annually, it'll compound quarterly. So if that's the case, how long will he have to wait to buy his console? It's not going to grow fast enough to give him the money in 1 year, right? 6% is growing much slower than 27%. So how much longer will he have to wait? Well, we're going to use the same formula, right? We know that the PV is the present value. That's $800. I is the interest rate per period, so it's not 6% per year. Sorry, that is the present value today. It's not 6%. We're going to take that 6% per year and divide it by the frequency. The frequency is quarterly, so 4 times per year. So 6% divided by 4 is 1.5%. This is the interest rate per period. And we know that we want the future value to be $899.99 times 1.13, because we have to add the tax, is $1,016.99. So this is my TVM solver. I'm going to plug in all of my values here, negative 800, 1016.99. The annual rate is 6%. It looks like with this solver, some of them ask you to actually put in the interest rate per period. This one I only needed to put in the annual rate. I said that it's compounding quarterly, and I just click on this button to find that the number of periods is 16.12. So it will take 16.12 quarters before Omid will have enough money to buy his console. $800 will grow to $1,016 in 16.12 quarters. But how many months is that? How many years is that? Well, there are 3 months per period, right? A quarter of a year is 3 months. So if I take my number of periods and multiply it by 3 months per period, this unit period will cancel out, and I'll just do 16.12 times 3, and that will be the number of months. It's going to be 48 months before he can buy his console. He will have to wait 1 year for the console to come out, and then another 36 months, which is 3 years. 3 more years he will have to wait while all his friends get the newest console with the newest games, and he is just sitting there with his last generation console still playing until his investment grows to what it needs to be.
If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.